Hey everyone! In this video, we'll learn how to train custom YOLO segmentation models using Ultralytics Platform. Segmentation models are a type of computer vision AI that can find the outlines or masks of each object in an image. They have uses in applications like self-driving, agriculture, robotics, and even fashion. This tutorial shows how to train YOLO segmentation models on Ultralytics Platform. It's an end-to-end model development system that makes it super simple to develop computer vision AI. I'll go through the process of gathering images and then labeling them on Ultralytics Platform with AI-assisted annotation, and training a model and then deploying it on your PC. I've even got a coupon code that will give you an extra $30 in free credit, which will basically let you train hundreds of models for free. I'll also show off my example VeggieVision application, which uses YOLO segmentation to calculate the volume and weight of common types of vegetables. VeggieVision makes it easier to measure out ingredients when following cooking recipes, and you can use the code as a starting point for your own application. This video is sponsored by Ultralytics, who are the creators of the Ultralytics library and platform that have made vision AI accessible to everyone. Thanks, Ultralytics. All right, let's get started. The first step in training a model is gathering images of your objects. These images will be fed to the model during the training process so it can learn what the objects look like. For a proof of concept model, we need to gather about 50 to 100 images of the objects you want to detect. The best way to train a model is to gather images using the same camera, lighting conditions, and perspective as will be used in the actual application. For my VeggieVision model, I set up a camera above my countertop to take pictures of vegetables from an overhead perspective. I bought a few different types of vegetables to use for capturing training images. I moved them around in a variety of combinations, positions, and orientations to get a good amount of variety in the dataset. I only captured images in my kitchen's lighting, but if you know you'll be using your model in multiple lighting conditions like indoors and outdoors, make sure to capture examples under each type of lighting. Take a look at my data collection video for more information on best practices for gathering images and building datasets. Once you've gathered all of your images, put them in a folder somewhere on your computer. We'll upload them to Ultralytics Platform, but first we have to make an account and set up a project. Open a web browser, go to platform.ultralytics.com, and click the Get Started Free button. When you sign up, you get $25 of free training credit if you use a company email, or $5 if you use a personal email. I've also got a coupon code that will give you an extra $30 of credit. Training a simple model only costs 5 or 10 cents, so even $5 goes a long way. Enter your email and click Create Account. Enter your information, and on the Data Region page, select the server closest to where you live to minimize latency. Finally, on the last page, we can use our coupon code for an extra $30 of credit. Enter EDJE-ULT and click Apply, and it will add $30 of training credits. Thanks, Ultralytics. Click Get Started to finish the sign-up process. This is the home page for Ultralytics Platform. Go ahead and click through the little tutorial. Okay. And from here, you can create new projects, annotate images, train models, and deploy them. Let's start by creating a new Annotate project. Click the plus sign by Annotate to open the New Dataset dialog. From here, you can upload all of your images by clicking and dragging them into the window. You can also just find them through File Explorer. I'll name my dataset Vegetables and Fruits 1. And since we're training a segmentation model, make sure to set the task type down here to segmentation. You can also set the visibility to private if you don't want to share your images. Click Create and Upload to create the project. And let it upload here. While that's working, you can also use the Explore tool to look for other datasets on Ultralytics Platform. Make sure to filter by the correct task, which in our case is going to be segment, since we're training a segmentation model. If you find one that has images that are suitable to your task, then you can click the Clone Dataset button, and it'll copy a version of this dataset to your account, which is pretty cool. Then from there, you can edit it to your heart's content. Once the dataset is uploaded, the interface will automatically select a train-val test split for your images. The typical train-val split is about 80% to 20%, but it's better to use 90% to 10% if you have a dataset that's only 100 or 200 images. So go ahead and set the train-val split to closer to 90% and 10%, and then click Apply. Then click the first image to enter the labeling interface. All right, let's start labeling images. First, I'll show how to manually create a segmentation label. Click the Add Class button to create a class like carrot, and then click Draw, and begin clicking the outline around the object. Creating labels for segmentation models takes a while because you have to draw the entire mask for the object. When you've labeled the full object, click the original point to close the outline and save the label. Let's do this for one more object just so we can practice it. Make sure the outline tightly hugs the actual shape of the object. If something's obscuring the object, don't include that in the outline. Creating segmentation labels takes forever, but fortunately, Ultralytics Platform has some helpful tools that really speed up the process. Click the Smart button to initialize AI-assisted annotation. Smart Annotation uses SAM3 to automatically propose masks for objects and images. With SAM3 active, click one of your objects, and it will automatically draw an outline. If your object doesn't stand out from the background very much, you might need to click a few more points inside the object, but usually it does a pretty good job with just one point. Press Enter to save the annotation. Now you can just click each object and save the outline. It's much faster than manually drawing every single outline. So I've got a cucumber and a cabbage hiding over here, so I'm going to add some new classes. Cucumber, and label that one. And a cabbage. And make sure you have the right class selected when you're using the auto annotation. If you make a mistake with your labels, you can just click the label, press delete, and then try again. Once you're finished labeling an image, click the next image in the bottom right corner. Annotating this image goes much faster with AI-assisted labeling. You can also use a pre-trained model to predict labels on your images. This can be an off-the-shelf model or one of the custom models you've trained or uploaded to Ultralytics Platform. Skipping forward a bit, I'll use my first iteration of the VeggieVision model to propose labels on this image. I've already uploaded this model to the platform and I can use it to generate labels for the objects. You can select the model from the drop-down. You can go to My Models and find your model. Then click Predict, and it will automatically propose labels. You can fix any issues by clicking the outline and clicking and dragging any points into place. Continue working through the rest of the images in your dataset. Overall, the auto annotation tool is really cool and it will save you a ton of time in labeling. Labeling still takes a while, so go grab a drink and put on some music while you work. Once you're done labeling images, you can start training a model. Close the labeling interface and click the plus by the train in the sidebar to create a new training project. I'll name mine VeggieVision 1. You can set the visibility to private if you don't want to share your models. Click Create Project to make the project. Alright, now click the New Model button to open the training dialog. In the Dataset section, make sure the dataset that you just labeled is selected. The Base Model section allows you to choose which model you want to train. So since we're training a segmentation model, we want to select one of the models in the Segment section. Next, we need to choose the model size. Smaller models like the YOLO26N option run faster, but they're also less accurate. The large models like YOLO26X take more compute power, so they run slower, but they're more accurate. This table shows the relative speed and accuracy of each model in the YOLO segmentation family. Generally, you should choose the largest model that will still meet the speed requirements for your application. I recommend starting with YOLO26S Seg because it strikes a good balance between speed and accuracy, and it can run with 10 FPS on most platforms. You can set other parameters like number of epochs and resolution in the next section. For datasets smaller than 1,000 images, 100 epochs is a good starting point. For larger datasets, use 50 epochs as your starting point. Resolution has a large impact on the speed and accuracy of a model. A lower resolution model will have higher speed but less accuracy. YOLO models are typically trained and inferenced at 640 by 640 resolution. However, if you want your model to run faster or you'll know you'll be working with low resolution images, try using a resolution like 416 by 416. You can also select what GPU to use for training. With small datasets, you can use less expensive GPUs like the RTX 4090, and it'll still take about the same amount of time to train. This saves money over using the default option. Once you've selected all of the parameters, click Start Training. Depending on the number of images you have, training will take anywhere from a few minutes to an hour. While training runs, the model metrics will update in real time. It's pretty cool. The MAP gives an overall estimate of the model's accuracy. The loss metrics are also helpful to watch during training because the loss should continuously decrease over time. When training finishes, it will display the model's final metrics. Again, higher MAP is better. To get a sense of how the model's performing, you can go to the Predict tab and select an image to test it with. Or you can snap a picture with your webcam. It's a great way to quickly gauge your model's accuracy. Once your model is finished training, it's ready to be downloaded and deployed in an application. YOLO models can run on a wide variety of hardware, including PCs, embedded systems, and smartphones. The Export tab allows you to export the model in formats that are optimized for various hardware platforms. You can check out my videos about running YOLO on the Raspberry Pi and Jetson Orin Nano for more information about which model formats are optimized for what hardware platforms. Generally, I like to keep models in the default PyTorch format until I've selected the hardware platform I know I'm going to deploy on. Next, I'll show how to download the model and run it on your computer with a live webcam using a custom Python script. Click the Download button to download the model in PyTorch format. Open your Documents folder or wherever you'd like on your computer and create a new folder called YOLO. Take the file that was just downloaded and move it into that folder. I'm going to rename mine to VeggieVision Model 1 just for keeping track of model versions. Okay, now we need to install Anaconda, which is a handy tool for creating Python environments on your PC. It lets you install Python packages like PyTorch without interfering with existing installations on your operating system. Open a new tab and go to anaconda.com/download, and then click Skip Registration and download the Anaconda installer for your operating system. Run the installer and use the default options. Once it's installed, search for Anaconda prompt in the start bar and open it. Create a new environment by issuing conda create-n YOLO env1 python equals 3.13. And then enter Y when prompted. Okay, once it's finished, activate the environment by issuing conda activate YOLO-env1. Okay, and then install Ultralytics by issuing pip install Ultralytics, and that's it. Okay, so this will install Ultralytics, OpenCV, PyTorch, and all the other Python libraries you need for running the YOLO model. Okay, if your computer has an NVIDIA graphics card, you can install the GPU-enabled version of PyTorch so that model inference runs faster. Go to pytorch.org/getstarted and scroll down a bit, select your operating system, and then select the CUDA version that you want to use. Usually just like the oldest one is the safest. And then copy this command at the bottom and paste it into your Anaconda prompt window. But then there's an important change we need to make. We need to add -- upgrade after install. Okay, make sure to add this or else it won't work. And then press enter, and it'll start installing the CUDA-enabled version of PyTorch. It's a pretty big download, and it takes a while to install. And again, only do this if your computer has an NVIDIA graphics card. Otherwise, it won't help. Okay, now that everything's installed, let's move into the YOLO folder by issuing cd documents/YOLO, or whatever the path to your folder is. I wrote a Python script called YOLO for running segmentation models on an image, video, or USB camera and displaying the results. Download the script from my website by issuing curl-o YOLO_segment.py and then https www.edgetech.io/code/YOLO-segment.py. Okay. Now you can run the model on your USB webcam by issuing python YOLO-segment.py, and then model is VeggieVision model1.pt, or whatever the name of your model is. The source is USB 0. It tells it to run on the first connected USB camera, and then resolution is 1280 by 720. Okay, so once it loads, a window will appear and it'll show, we'll run inference with your YOLO segmentation model, and it'll display the detection results on each frame. And so this model definitely runs fast. You can see it's running at like 25, 30 frames per second on this. Looks like it struggles with the carrot a little bit. Let's try a cucumber. But yeah, just a quick way to deploy and test your model with a webcam and see if it's working. Seems to be doing pretty well. So once you've tested it to your heart's content, you can press Q to quit the program. You can visit the GitHub repository for more information on how to run the YOLO segment.py script. Okay, so now that we've got YOLO segmentation running on our computer, what can we do with it? Well, as an example, I made an application that I call VeggieVision. If you do any cooking, you know that recipes often call for ingredients like 3 cups of potatoes or 500 grams of some vegetable or 1 pound of carrots. But how are we supposed to know how many potatoes it takes to get to 3 cups of potatoes? With VeggieVision, you can place common fruits and vegetables underneath the camera and it will estimate the length, volume, and weight of each item. It takes the outlines found by the YOLO segmentation model and calculates the volume using spherical estimation or disk integration. It reports the total size and weight of all the ingredients in the camera frame, so you can use it as a sort of digital scale when you're measuring out food for your next recipe. Right now, it works with carrots, cucumbers, cabbages, potatoes, onions, apples, and tomatoes. I uploaded the VeggieVision code to GitHub, and you can find a link in the video description below. It gives a good example of how to parse mass coordinates and work with the results. You can use it as a starting point for your own applications with segmentation models. In the next couple of weeks, I'll post a brief video explaining more about how VeggieVision works, so keep an eye out for that. Congratulations, you now have a custom-trained YOLO model. Check out my GitHub repository for more examples and tutorials showing how to use YOLO. Big shout out again to Ultralytics for making the cool and highly useful Ultralytics platform. And thank you to you guys so much for watching this video. Good luck with your projects, and I'll see you next time.